Graphs of rates are common in calculus. While the horizontal axis in such graphs may stand for many things, it often stands for time. The vertical axis stands for some indicated type of rate, often with respect to time. In rate graphs, a point on the graph represents a value of the indicated rate at a certain time, and for that we would write it in units per time. A slope represents a rate of change of that indicated rate, units per time per time. And the signed area between the graph and the horizontal time axis represents a definite integral which has undone the indicated rate to produce an accumulated value. In this context, an integral may be thought of as an accumulator. The second part of the fundamental theorem of calculus states that the accumulation function is just a particular antiderivative of the original function. Equivalently, the derivative of an accumulation function for a function f is equal to f of x itself. For example, if we're integrating a rate like velocity is the rate of change of position, by fundamental theorem of calculus, the integral would be the position function evaluated from a to b, which is equal to x of b minus x of a. Hey, that's final position minus original position, displacement. And this is how the integral can be seen as an accumulator, because the result of the integral of a rate is displacement, and displacement is the accumulation of the positive areas and negative areas.
The graph at right models the rate of rainfall in inches per hour from midnight until 6 a.m. during a tropical rainstorm. Include numbers and units in parts A, C, E, G, and I. A. Write a complete sentence to explain what point A on the graph represents. Because point A is 3, 1, at 3 a.m. rain falls at a rate of 1 inch per hour.
The slope between points A and B is clearly 0. To write a complete sentence to explain the meaning, remember that the slope of a rate graph is the rate of a rate.
The rate of change of the rate of rainfall between 3 a.m. and 4 a.m. is 0 inches per hour, showing no change.
To find the slope between B and C, we just look for delta y over delta x. Delta y is 1, that's in inches per hour, and delta x is 1 hour. The slope between B and C was decreasing, so that would be a slope of -1. Again, slope of a rate graph is the rate of change of rate of change.
The rate of rainfall decreases at a rate of 1 inch per hour.
To find the integral of r of t from 3 to 5, we're going to find the area between the curve and the x-axis from 3 to 5. Because this section is in the shape of a trapezoid, we can just use the area of a trapezoid formula from geometry. So our height is 1, the lower base is 2, and the upper base is 1. Remember, the result of the integral of a rate graph is just giving you an accumulation over this interval. This is how much rain fell.
Between 3 a.m. and 5 a.m., 1.5 inches of rain fell.
To use geometric shapes, I saw that there was a triangle from 0 to 3, a trapezoid from 3 to 5, and then no area from 5 to 6. The area of this triangle would be 1/2 times base times height. We already figured out this integral, and that was 3/2. And this has no shape, so 0. Uh-oh, Aurelie made a mistake. See how this says approximate? That means these equal signs should be squigglies, approximately. Remember, the integral of a rate graph is an accumulator, so this right here would tell us how many inches of rain fell from midnight to 6 a.m.
From midnight to 6 a.m., a total of 3 inches of rain fell.